Some chemical reactions are slow. For example, a car can take years to rust. Other reactions are fast, like fireworks exploding into colourful sparks. How fast a reaction happens is called its rate.
Variables that affect the rate of reaction include temperature, surface area of reactants, and the concentration of reactants. The rate can be calculated by measuring how quickly the product is made. The rate can also be measured by how quickly a reactant is used up.
Before carrying out an investigation, you should be able to write a hypothesis. This is a general statement saying what you think will happen. For example, increasing the concentration of reactants will increase the rate of the reaction is a hypothesis. You should be able to support your hypothesis with a scientific explanation. In this case, increasing the concentration of the reactants will increase the number of particles in a given volume, so the chance of a successful collision between reactants is higher, increasing the rate of product formation.
We will take a look at two different methods of investigating how the concentration affects the rate of reaction. Method 1. Observing colour change.
The reaction between the colourless solutions sodium thiosulfate and hydrochloric acid produces sulphur, which is a yellow solid. You can measure how long it takes for a fixed amount of sulphur to be produced. This gives an indication of the rate of reaction. You will use a range of concentrations of sodium thiosulfate. These can be made by diluting an initial solution with water.
A conical flask containing hydrochloric acid is placed on a white piece of paper onto which a cross has been drawn. The sodium thiosulfate is added and a stopwatch started. You look down the conical flask through the solution, which will gradually go yellow. The stopwatch is stopped once the cross can no longer be seen.
This is repeated 3 times for each concentration and a mean calculated, making sure to leave out any anomalous results. A line graph with a line of best fit is plotted using mean time taken for cross to disappear in seconds on the y-axis and sodium thiosulfate concentration in grams per decimeter cubed on the x-axis.
The graph shows that the hypothesis is correct. As the concentration increases, the time taken for sulfur to form decreases. This means that the rate of reaction increases as the concentration increases. However, the results from this method are not very accurate. Deciding when the cross is no longer visible is subjective. It is based on a person's opinion. This is why it is important to repeat the measurements. Repeating the measurements and calculating a mean will increase your accuracy.
Method 2. Measuring the volume of gas produced. In some reactions, the product is a gas. For example, the reaction of a metal with an acid produces hydrogen, and the reaction of a carbonate and an acid produces carbon dioxide. For both of these reactions, the gas produced is collected and its volume measured.
The acid is placed in a conical flask with a delivery tube attached. This tube delivers the gas produced to a measuring cylinder full of water. The gas pushes the water out of the way and collects at the top of the measuring cylinder, so its volume can be measured.
The metal or carbonate is added to the acid and the bung fastened tightly. It's important to make sure no gas escapes from around the bung. The first few bubbles of gas produced will be air from the apparatus. This doesn't matter because the air is being pushed out by the gas being made by the reaction in the flask. Now, move the delivery tube under the measuring cylinder and measure the volume of gas every 10 seconds for 100 seconds. Repeat this 3 times for each concentration of acid.
An alternative is to use a gas syringe to measure the volume of a gas produced. If a gas syringe is used, then it is important to make sure that the plunger is pushed all the way down before starting the experiment, and that the plunger is not wet, as this will cause it to stick.
The line graph produced this time will have volume of gas produced in cubic centimetres on the y-axis and time in seconds on the x-axis. You would plot 2 lines on the same axis, one for each concentration of acid you used. Some experiments will specify a minimum of 5 concentrations, so be sure to check with your teacher. If so, you would simply plot extra lines for the additional concentrations.
The line from the higher concentration has a steeper gradient. This shows that the rate of reaction is faster. Calculating the gradient of a line at different times will give you a measurement for the rate of a reaction. At the start of each reaction, the line is straight. The gradient of a straight line is easy to calculate.
The gradient is the height of the straight part of the line divided by the width. The gradient will give you the rate in cubic centimetres of gas per second. In the example shown in the image, it is 10 divided by 2, which equals 5 cubic centimetres per second.
To calculate the gradient of a curved section of the graph, you need to draw a tangent. A tangent is a straight line that touches one part of the graph. The gradient of the tangent is then calculated. In the example shown in the image, the rate is 4 divided by 1.6, which equals 2.5 cubic centimetres per second.